Yeah, hello friends. So, myself Shant Agarwal. Today we are going to study this Young's double slit experiment. So this is a very wonderful topic of physics for JEE Advanced and JEE Mains as well. So now let us start. So firstly, first before moving to YDSE, I would like to brief you about some interference and this the interference of light waves. Like this thing is because this is important to understand before going to YDSE. So what is yeah. So first we see what is interference. So actually, here we are seeing interference of light rays. So as you know, light has two natures. Light has dual nature, particle nature and wave nature. But for studying interference, we will see the wave nature. We will deal with the wave nature of light. Correct. So what we understand about why interference. So whenever I see interference means when the two waves are moving and two coherent waves are moving and they are superimposing. So there at the meeting point of that waves, the resultant intensity is something different from what the individual intensity of the waves are. So that might be equal to but after resulting that may come to some other value that may become here we understand. I'm saying this is source 1, this is source 2, this is wave 1, this is wave 2, and they are meeting at one point. So the superimposition, here the superimposition of this waves are taking place at this point. Like intensity of this wave is I1 here at this point, and intensity of this wave is I2 here at this point. But the resultant intensity which will come, that will be something else. Correct. So that we will see how we can find it. So let us move. Right. So how to find this intensity at this point of superimposition by these two waves. So I am considering a simple wave equation, y1 equals to a1 sin omega t, y2 equals to, and another this is sin omega t plus pi. One thing which is very important in this interference thing is these sources, these waves should be, these sources should be coherent. This word is very important. Why? What it means to be coherent? Coherent means the frequency of the sources should be same, and the wavelength of this wave should be same, and the phase difference between these two waves should be either zero or should be constant phase difference. Like here we see what is the phase difference? Omega t plus phi minus omega t. That will come as phi, which is a constant phase difference. It should not come in terms of omega in terms of time. That will not act as coherent source. So these are the two waves, y1 and y2. If I want to find the resultant, so I can take as this will be equals to y1 plus y2. Correct. So if I see a1 sin omega t plus a2 sin omega t plus phi. If I open this formula by the sin a plus b formula, so that will come as plus a2 sin omega t cos phi plus cos omega t sin phi. Correct. So if I take the like common things, so a1 sin omega t, and this sin omega t I can take as common. So a1 plus a2 cos phi sin omega t plus what is remaining, a2 cos omega t sin phi. So I am writing it as a2 sin phi cos omega t. Correct. So if I say like here we can manipulate something. So if I say this as a cos theta and this as a sin theta, I am taking it as like arbitrary a and like arbitrary theta. So this will come as like this will become a cos theta sin omega t plus a sin theta cos omega t. So this will become like sin a cos b plus cos a sin b. This will become a sin omega t plus theta. Correct. So now as we have written, I am erasing this thing. As we have written, a cos theta is a1 plus a2 cos phi and a sin theta is a2 sin phi. Correct. So from here I can find the angle theta. How? By dividing these two equations. This is 1, this is 2, I am doing 1 divided by 2. So this will come as tan theta equals to a2 sin phi divided by a1 plus a2 cos phi. Correct. And also like how I can find this a variable, like if I square these both equations and add them, so how will it come? This a square cos square theta plus a square sin square theta. So a square common, a square I can take as common, and sin square theta plus cos square theta will become 1. So a square equals to whole square, this is a1 plus a2 cos phi whole square plus a2 sin phi whole square. Correct. So I can write as it a as, if I open this will come as a1 square, this will come as a2 square cos square phi square, and from here a2 square sin square phi sin square phi. So this will become again a2 square, so a1 square plus a2 square plus this will come as 2 a1 a2 cos phi. And under root of this. So here from here I can find this like parameters which I have taken as arbitrary constants. This will like look like something addition of two vector, like which are like parallelogram addition of two vectors. Like these are the two vectors a1 a2 and these are making angle phi. So if I am making this parallelogram and this the resultant term is like angle theta, so I can write it as like tan theta by this formula, and this resultant value I can write it as this formula. So by this we can also see. So like now I find this resultant there. Okay. So we see how we can find it intensity. Like before we see like when two waves are superposing with each other, at some like distance, so they are causing some resultant intensity, you know, to like coming as a new intensity at that point. So how we can find that intensity? How we can find that intensity? So we will see here from here. So actually, like if you know, the intensity is always directly proportional to square of amplitude. Correct? Square of amplitude. Like whatever is the amplitude of this wave, by that square, by square of that makes up like proportionality constant with intensity. And so intensity is proportional to how much is the amplitude of my wave. So if I remove this proportionality constant, so I can write it as A equals to some k constant and A square. Correct? Okay. So what my A comes as, like if I see from previous equation, my A came as root over a1 square plus a2 square plus 2 a1 a2 cos phi. Correct? So if I want to find the intensity of this wave, so I can write it as I resultant equals to k. A square will come as a1 square plus a2 square plus 2a1 a2 cos phi. Correct? So this will come as k1 square plus k2 square plus 2ka1 a2 cos phi. So what I can write is like this. What I can write, because this a1 is amplitude of this y1 wave, right? So I can write it as like I1 intensity which is causing by this wave, which this intensity which is carrying by this wave, so that I can write as k1 square. So this I can replace by I1, this I can replace by I2, and here I can write as 2 root I1 I2 cos phi. Correct? This is I result. So my intensity comes like this, and my like amplitude came like this. So now get this, you can get this. So now we are going to find, like there are two types of like if like waves are interfering with each other. So there are two possibilities. Like intensity will be like after interfering with each other, like the resultant intensity can be can take a maximum value or can take a minimum value, right? So it will take a value between minimum to maximum. So we are going to find how, like what is the minimum value and what is the maximum value. So when the value is maximum, so like when the value is maximum, that is going to called as, like that situation is going to called as constructive interference. Constructive interference. So when this value of intensity will be maximum, so here I1 is fixed, I2 is fixed, 2 root over I1 I2 is fixed. So what thing I can maximize? This is cos phi. Only this thing I can maximize. So the maximum value of cos phi will be 1. Maximum value of cos phi will be 1. Only at that time I can maximize this value, this intensity value. So what it will come? It will come this way. This intensity will come as I1 plus I2 plus 2 root over I1 I2. So if we look carefully, this can become a formula of root I1 plus root I2 whole square. Correct? Similarly, how I can find the minimum value? Yeah. Like when cos phi equals to -1, that time it will come as minimum. So it will become I1 plus I2 plus root over I1 I2 minus 2 I1 I2, right? This will come like this. So this will become root over I1 minus root over I2 whole square. This is the minimum intensity. And this is Imax. Correct? This case is called as destructive interference. Destructive interference, right? So I can erase this. Yeah, so we have seen like this destructive interference. Now let's see like if I say here that A1 equals to A2 equals to A, I'm taking this like some arbitrary, like I'm taking this A1 and A2 is equal. Now obviously A1 and A2 will be equal, but I1 and I2 will also be equal, which I am taking as I0. Correct? So now I want to find the resultant intensity that will be at the point of superimposition. So that will come as I1 will be taken as I from this formula, like plus I plus 2 root over I square and cos phi. Correct? So from here the I will come as common, 2 also come as common, 1 plus cos phi. And I know that like formula of this cos phi is 2 cos square phi by 2 minus 1. So what will come as 1 plus cos phi? I can write it as 2 cos square phi by 2. So this will come as 2 multiplied by 2 for this is I naught, I naught, I naught, I naught, I naught cos square pi by 2. So resultant intensity will come as this. If I1 and I2 equals to I0, if the intensity of both the wave are same, then the resultant frequency will come as this. So if I see the maximum value of I, what can be the maximum value of intensity? What can be the maximum value of intensity? Because cos square pi by 2 can be maximum. If I maximize this, this can be go to as 1. So the I max will come as 4I0 and minimum value of this will go as 0. So I min will be 0. This is very, very important. This will come in use of us in further, like when we study YDSE. So this is the important thing to note down. So Imax from here comes as 4I0 and I will come as 0. So when will be Imax? When this constructive interference will occur, and why this? When this I will occur, then when this destructive interference occur. Right? So I think this is perfect for interference. Now we can move to our main topic, which is YDSE for today's. YDSE, Younge's double slit experiments. Actually, it is very good topic to understand. Very conceptual and clear cut. If you understand it clearly, the derivations are very clear. If you understand very clearly, you can solve any question of YDSE. It is very easy to solve, but the concept should be clear. So YDSE, I am writing it as full form. Younge's double slit experiment. In short form, we call it as YDSE. So, what is this Younge's double slit experiment? What happened? Like in this experiment, we take this cardboard type of thing, and we take these two spacings called as S1 and S2. The light waves are coming from this side. These are the light waves, and from some distance, from this is the screen, correct? So this is the screen, and this is the cardboard. How can you visualize this? If you see, we have made some in a cardboard, there is a cardboard. We have made two cuts in this cardboard, these small openings. So from these openings, we are going to pass the light array, and that light array is going to interfere in this screen, and we are going to observe this what will happen, what is the behavior of this interference of these light rays in this screen. So that we are going to study. So the light rays are coming this. So wavefront, if you have studied, so these are the wavefronts, because they are perpendicular to the rays. So when they come to this, so these two openings will now become a new light source. New light source for this interference. They will act as new light source. And because we are taking this only one light source so why we are taking this type of thing for interference and only one light source? Because what happened, we have studied for interference we need coherent sources, and for coherent sources what it mean? Frequency should be same, wavelength should be same, and the phase difference should be constant. So to make the frequency same, even if a same company is making two bulbs, there is possibility to have some differences in these two bulbs, because they cannot make exactly the same all things. Frequency can be different, or some things can be different. So we are taking only one source only, one light source only, so that the frequency will come as same. So these two sources will now act as coherent sources. These two small objects, correct? So from here we can erasing this wavefronts. These are just for understanding. So from here, when the light sources are light will come here. So when they come, they will interact. When they meet here on this screen, they will interact with each other, correct? So if I say like these waves are interacting each other, yeah? So when the this different intensity will come, the resultant intensity, when it comes, like some path difference should be there, some phase difference should be there. So what is path difference? Like what we understand by path difference? Like these are two sources. So these two sources are there. So why this resultant intensity? This resultant intensity differ because of this. This is doing some. This is traveling some x1 path. This is traveling some x2 path. So like some path difference is coming up. So because this is traveling another path x2 and this is traveling x1 path. So the difference of path, that is called as path difference, because this path differences, this phase differences, this path differences, this different intensities comes, resultant intensities. So that only we are going to see here, and this is very important in this experiment. So yeah, so when these these two waves are interfering here at this central point, like this is the middle central point of this this distance. This distance we call as d. This is the d distance. We call it as slit distance. Slit distance d, and this distance we call as capital D. Slit to slit distance, this is called as capital D. Denoted as capital D. So when these two two waves are interfering each other, so what is the phase difference, path difference? Like because these are same, so no initial phase difference are there. And what is the path difference? Path difference is also 0 because they are traveling same distance. These distances are also same, and this is also same. So here, when we have seen that I max equals to over I naught and I min equals to 0. From where it came? I equals to over I naught cos pi by 2 cos square pi by 2. So here the path difference is 0. So cos pi will be 0. So here the intensity will become as, so path difference, we denote path difference as delta, that will come as 0. So intensity will be 4 I naught. Intensity will be 4 I naught. Correct? Yeah, so before going deep to this, one concept more I want to make you. So 4 I naught cos square pi by 2. This is the value of intensity, correct? So to make it maximum, this cos square pi by 2 should be 1, correct? 1 or minus 1 or minus 1. So for that, pi by 2 should be n pi. To make cos square pi by 2 as 1 or minus 1, pi by 2 should be n pi, correct? So pi should be 2n pi. 2n pi. So we see the formula that delta, this is path difference, delta equals to lambda by 2 pi or delta pi. This is phase difference. So what should be the delta for maximum value of intensity? Lambda divided by 2 pi, and delta pi should be 2n pi. So 2 pi will cancel out, and this is come as n lambda. N will be like some integer 0, 1, 2, 3, like this. Like pi, 2 pi, 3 pi, 4 pi, 0, these things. So delta should be n lambda. For what? For I should be maximum. For constructive interference. delta should be n lambda. Similarly, for destructive, this cos square pi by 2 should be 0. This cos square pi by 2 should be 0. So pi by 2 should be 2 n plus 1 pi by 2. Correct? So this will cancel out and pi should be 2 n plus 1 pi. So what should the delta? Delta should be lambda by 2 pi 2n plus 1 pi. So from here it comes 2n plus 1 lambda by 2. This should be the delta for minimum interference, for destructive interference, for the minimum value of intensity. Correct? So here delta should be n lambda. So if we put value of n as 0, so here this will come as 0. So this will call as maximum intensity. If somewhere, like if these waves will interact here, these waves will interact here, and here the value of delta is coming as lambda by 2, right? From here it is, if we are putting the value of n is 0, so this will come as lambda by 2. So it will cause, yeah, I will erase this. It will cause minimum intensity, which is 0, and here delta is coming as lambda, which is, it will cause n lambda should be. If we put as n as 1, so this delta is lambda. So this is satisfying the condition of maximum like constitutive interference. So this here the intensity will be 4i, correct? So these are the things will go. So now we'll see how to like calculate the intensity at some point. Like here we are saying that at lambda by 2, at lambda is equal to lambda, like these points are interfering. So there they are making some like interference. So now we'll see how to calculate. Before that, if this lambda is 0, so intensity is maximum. Intensity is maximum. Where the lambda is coming as 0, this point we called as center maximum. This point we called as central maximum. Correct? It is not necessary that central maximum should be at center of this only. We will see further how it will go up and down. Like, but where the delta should be 0, delta is 0, that point is called as central maximum. And here the intensity will be 4i naught. So 4i naught. Okay. So this will be the very bright region, correct? And where the intensity is 0, this will be a dark region. So how the fringes, how the pattern will pattern will become on this screen. That like let me just show. Let me just show. This is the screen and this is the center line. Okay. So if this area is bright, so like this, consider this blue line as bright region. So this will come as like this, and again like this will like fade, and again this will come as this dark region, bright region, and consider this white portion as dark region. This is dark, this is bright. Again this will come like this. So these are the this fringes will become. Similarly below also. These are the fringes will become. These are like bright portion, dark, then bright, then dark, then bright. So these are the fringes. This pattern will become on this screen. It is very wonderful if we see, like if we can perform it in our like home also. We can make a slit, take a cardboard, make two lines, two cuts, and just throw on the right, turn off the all other lights also of room, then you can see the development of fringes on the opposite screen. Okay, we see the calculations of this in this experiment. What are the necessary calculations we need to perform to solve the questions of JEE Advanced and JEE Mains. Okay, this is the Slit S1, S2. This is the screen. This distance I am calling as D. This distance is small d, slit distance, slit gap. Like if I am considering these two waves are interacting each other at some point, P here. Okay. At some point P here. This is making an angle theta. This point is making an angle theta. At the center of the slit. At the center of the slit. So, because one assumption we have to make, also this is true also, that D is very less than capital D. This distance is very greater than this compared to this small distance of D. So if I see the path difference between these two waves, this first one, this second one. So if I draw a perpendicular to this, so if this theta is very small, like if this D is very small to capital D, so I can consider this like S1P as equals to, if I am taking as Q, this PQ is equals to S1. So I am taking this value as equal. So what is the path difference? That will be equals to S2Q, because these two things are same. So what extra this wave has traveled? This is S2Q. So this is D, this is theta, this is 90 minus theta, this is again theta. So this distance can come as D sin theta. Correct? This is right angle. Understand this. This is S1. This is Q. This is S2. This distance is D. This angle is theta. So what will, and this is right angle. So what will be this distance? This x. If I am taking this x divided by D plus sin theta, can I write this? Correct. So x will come as D sin theta. Okay. X will come as D sin theta. So this can come as. So if I see the actual path difference is here, so that is only D sin theta. So actual path difference here is D sin theta. Yeah. Actual path difference here is D sin theta, which is equals to delta, which I also can write as lambda divided by 2 pi delta y, that we have seen previously. So if this theta is very small, so we can write as d theta only, that is equals to lambda by 2 pi delta y. Correct. If I am taking this distance as y, so y divided by d will be equals to tan theta. That will also be equals to theta, because theta is very small, correct? So from here theta is come as lambda by 2 pi d. So y d will be equals to lambda by 2 pi d delta pi. Or if we see like for maximum delta should be equals to n lambda, and for minimum delta should be equals to 2n plus 1 lambda by 2, which we have seen previously also. So here I can see d theta equals to delta. If I am putting delta as n lambda, so d theta is coming as n lambda, and theta is coming as n lambda by d. N lambda by d. Okay. I am raising this. Theta is coming as n lambda by d. This is for maximum, for bright flames. For maximum, theta is n lambda by d, which is equals to, from here theta equals to y by d. So y is the point where, like in this case, y will come as n lambda capital D by small d. This is the distance y from the central maximum, from where the bright fringe will occur. So n is, like if I put n as 0, so where like this, where y value will come as 0. So first here will be the central maximum, and first bright fringe will occur at, like if I put the value of n as 1, so first bright fringe occur at lambda d capital D by small d. If I put value of n as 2, then second bright fringe will occur at then 2 lambda capital D by small d. Like that we can find the distance of bright fringes, and also if I want to find the distance of dark fringe. Okay, so for that the delta value, this delta value here should be 2n plus 1 lambda by 5. So so theta will come here as for minimum, theta will come as 2n plus 1 lambda by 2 divided by d, which is equals to this y by d. Again this y by d. So y will come as 2n plus 1 divided by 2 lambda capital D by small d. This is for dark fringe. This is for bright fringe. This is for dark fringe. Okay. So for dark fringe, if I want to find the nth dark fringe, I can find by this formula, like distance from the central maximum. If I want to find bright fringe, the distance of bright fringe from central maximum, I can find by this formula. So now we see there is a term called fringe width, right? Fringe width. So fringe width, how we can define fringe width? Like fringe width, is something like the distance between two bright fringes or two dark fringes, two consecutive bright fringes. The distance between two consecutive bright fringes, that is called as fringe width, and the distance between two consecutive dark fringes, that is called as fringe width. Either of one we can take. So the distance of nth bright fringes we see n lambda capital D by small d. If I want to find the distance between two consecutive, so one is n lambda capital D by d, another will be at n plus 1 lambda capital D by small d, another bright fringe. So y2 y1. So if I want to find the fringe width we denote as beta. Beta is fringe width. That will be equal to y2 minus y1. This will come as n plus 1 lambda d by small d minus n lambda d by small d. This will come as lambda d by small d. Correct? This is fringe width. Very important formula. You can remember this also. It came very much useful for JEE Advanced and JEE Mains also. If I can find this by using the formula of minima like dark fringe, that will also come as same. You can perform that on your own also. Okay, so this is Younge's double slit experiment. This is Younge's double slit experiment. And this we have seen till now how to find the distance of dark fringes or bright fringes from the central maxima, and how to see like how to find out this fringe width. Okay, and what else we see? We see the assumption here that is also very necessary. D less than capital D. Remember that this assumption will take for calculation. If suppose like also we have taken this assumption that theta is very small. If suppose in some question that theta is given as 30 degree or 60 degree, that time you cannot take this sin theta directly as theta. That time you have to solve from basics only. So that's why it is very important to understand basics very clearly, so that at any point of time you can like clearly solve the problem according to the design question. So also we have seen for maxima the value of delta, the path difference should be n lambda, and the value of delta path difference for minima should be 2n plus 1 lambda y2. Okay, now we see something more in it. Something more in it. Okay. So we see here the interference is occurring because like this path difference is coming. So that's why this different intensities are coming. So why this path difference is coming? Here so we see that because this wave is traveling some extra path than this. That's why this path difference is coming. So how can these path differences can occur? First is like physical path difference. By physical distance, which is this case only. Like this, in this case, physical or geometrical distance you can say. Yeah, that will be the more clear term, geometrical distance. Geometrical distance. Okay. Second is if like this two waves having initial phase difference only. Here so this like light source is same only. That's why no phase difference is there. If suppose some phase difference is there, so that is also a cause of path difference. So initial phase difference. Initial phase difference. Third is optical path difference. What is this? This we are going to understand now. Optical path difference, because this is very important in JEE Advanced. This direct question will not ask, but this will give the question by modifying very much things. So this we are going to understand how this path difference, optical path difference. What is this? So suppose I am taking this slab of width W. Its refractive index is mu. Okay. And these two ways are traveling. One is this, one is this. One is traveling through this. One wave is traveling through this slab, which is of refractive index mu, and one wave is traveling through air only. The refractive index of air is mu, may not equals to we are taking as mu, which is 1 only. Okay. So if I say the speed of this light wave is in air is c. Okay. So what is the speed of this light wave in this medium? That will be, here the velocity will be c by mu, correct? C by mu. So for traveling this width w, how much time this this wave will take? So we know velocity equals to distance on time. Time equals to distance divided by velocity. Distance is like this w width. W width. This velocity is c by mu. This much time. This wave will take to travel through this slab of refractive index mu. Okay. So in that time, how much this wave will travel? How much this wave will travel? Because they are traveling simultaneously. So how much this wave will travel, which is in air? So this will travel with normal speed, which is c, into time. What is the time taken by this? This is w mu by c. So how much distance it travels? Mu w. Mu w. Mu will be greater than 1. Mu is greater than 1. Mu is greater than 1. So in the time in which this wave travel from the like w width in this slab, in this medium, like this wave travel mu w distance. So what extra path this wave which is in air, that covers? So that covers the extra path mu w minus w, because this travel w and this travels mu w. So what is it? Mu minus 1 w. Correct? If I am introducing a slab of width w in the path of like light ray, so the light rays which are passing through this slab, they are lagging by how much path, how much length? Mu minus 1 w from the other waves which are passing through air. So that is causing path difference here. Correct? That is causing path difference here. So why I am explaining this concept here? That will going to come here in this YDSE experiment. Okay, this is the I will use this. I erase this. Till now, the waves are interfering with each other simply. But now, what new thing I have done? I have introduced a film of refracting index mu and thickness T in front of this one slit of light. In front of this one slit. So how this is going to make changes in our this experiment? Let us understand. When this wave is traveling here, geometrically, so they both are traveling the same distance. But because we have seen this wave will lag how much? By mu minus 1 omega. Not lag, Why like? Because this will travel extra distance. In this path, this t distance will be equal to this t thickness, t distance will be equal to mu minus 1, will be equal to mu t in air, So how much the path difference will came in these two waves. So this is traveling how much extra? Mu t minus t. If normally it have to travel in air, then this wave could have traveled t. But now it is traveling mu t. Correct? So how much extra it is traveling? Mu t minus t. That is mu minus 1 t. That is the path difference. It is covering here. Okay. So here the delta is not going to 0. Here the delta is not going to 0. But it is equals to mu minus 1 t. So if delta is not going to 0, central maximum will not going to become here. So if we see some point here, where the distance for this lower opening will be more, and this for this should be less geometrical distance. So there is a possibility of this delta is 0. So what is this? This is y. This is y. This is y. And how we can write y as? We have written y as n lambda dy x small d. Okay. I am writing this y as n lambda small dy d. So here the delta should come as 0. Delta should come as 0 here. But at the distance of y, what my delta is coming as? My delta is this is my delta. This is my delta. Am I writing correct? See here. Because if for maximum we are writing y as n lambda capital D. In that maximum is n lambda we called as delta. So what we can write as y is equals to delta capital D small d. So delta is coming as y d by capital D. Is it right? So I am writing delta as y small d divided by capital D. So if I have to make this delta as 0, so this y d by small d should be equals to this extra delta which is coming by this thin film of refractive index mu. So this is mu minus 1 t. If this becomes equal to this path difference is causing due to this geometrical distance, and this path difference is causing due to this. If this will cancel each other, then this path difference can become 0. Correct? So what should be the y? Y would be mu minus 1 t capital D y small. That will be the y where the new central maximum will become central maximum, because delta will become 0 here. Delta will become 0 here. So there the new maximum will come. So what we are seeing here, when we are introducing this small film of refractive index mu, this central maximum is shifting upwards. Shifting upwards. Upwards means, like if I have introduced this, if I would have introduced this film into in front of this rather than this, then this central maximum should have shifted down. Okay. So they are playing an important role. Yeah. So I think this is all for this lecture. We have understand how to see this YDSE experiment, how to analyze this YDSE experiment. We have seen how to find the fringes, the bright fringes, the dark fringes, the central maxima, how to find the distance of this bright fringes and dark fringes from the central maxima, how to find the fringe width, and how to see these cases when such thin films of like some different refractive indices introduced in front of one slit. So front of one slit. So that also we have seen. Yeah. Further, many more things are there in this YDSE, which we can see in like some later time. So for today, I think this is okay. Yeah. One more important thing which we have studied in this interference thing, that the sources should be coherent. Otherwise, these all things will not work, because interference phenomena will occur when the sources should be coherent. So thank you all for seeing this video. Thank you very much.